My name is Ethel Webi, and I am a biotechnologist, and I would like to share with you my story. Back in 2016, I was a Master of Science student at Jomo Kenyatta University here in Nairobi, Kenya. And at the time, I barely slept. The few times that I slept, I will dream of this fungus that causes late blight disease growing like grass on a field. And I will be running around this field on shaky legs with sweaty palms. I was so anxious, and I hated that this anxiousness was in my dreams. So if you do a master in science, there are two parts to it. The first part is the classwork, where you do your written exams, and the second part is the practical work, where you do your research work. And I had been lucky enough to get a graduate fellowship with International Potato Center. International Potato Center is commonly referred to as SIP. So I was doing my graduate fellowship in SIP, which is my part of my research work. And at the time, I joined a group of scientists who are trying to find a solution to late blight disease that affects potato through genetic engineering. So late blight disease is a disease that is devastating for farmers all over the world. It's famously known for causing the 1840 famine in Ireland. So what happened was so many people were growing potatoes in Ireland, and they were relying on it for their livelihood. And then late blight came along and it destroyed all their crops. As a result, 1 million people died and 1.5 million people had to migrate to a different area because they could not afford, they did not have anything else to eat. So even to this day, this disease is still devastating. When it hits a farm, it can cause up to 100% yield loss. And it does not affect potatoes only, it affects tomatoes, among other crops. So when I joined this team of scientists, they wanted to find a solution to late blight disease that does not include the control methods that are available at the moment. At the moment, the way to control late blight is by use of fungicides. And you know fungicides are harmful to our health and they're also harmful to the environment. So if a farmer has to spray their farm at least 2 times a week to control this disease. And you know, if you spray fungicides, every time you spray, you leave toxic residues. And then, and you keep on spraying and spraying, you degrade that land. And so you have to leave that land and move on to the next. And then, you know, it takes so many years to restore degraded land. So we cannot keep on doing that. You move on to the next, move on to the next. In the end, we will not have any land to grow our crops. So I felt like these scientists were doing something noble because they were trying to find a solution to the disease that does not include the use of fungicides. And I was so happy to join them because I felt like they were doing something noble for the world. So at the time, when I joined these scientists, I was given 3 goals to do for my work. They had developed these potato varieties that they believed to be resistant to late blight. And they did this by transferring genes from a wild potato into these local potato varieties. So my work, the first thing I had to do was to confirm that these local potato varieties have this resistant gene. And I did that successfully and I finished. The second work that I had to do was to test these resistant varieties and confirm that they actually have that resistance. And for me to do that, I needed to grow the fungus that causes late blight disease. So in order to grow this fungus, I needed to go to the field, get the fungus, come back to the lab, grow it in the lab, and then infect these potato varieties and observe their reaction. So that's what I did. They gave me a procedure for making a mixture of ingredients that is used to grow this fungus. So I went to the farm. A lot of potato farms are usually affected by this disease. So I went to the farm, I got the fungus, I came to the lab, and then I grew the fungus. I placed it on this mixture of ingredients and I waited. But then it did not grow. I went back to the farm, I came back to the lab, I placed the fungus on this mixture of ingredients and I waited. And then nothing grew. So I did this back and forth for a whole month. Keep in mind that at this time I had only 6 months left to finish my graduate fellowship. And then I've wasted already 1 month trying to grow this fungus and it's not growing. So now I have 5 months left. And at the time I became very anxious. I used to see my supervisor and my heart would just race and I would sweat because I didn't want him to ask me about my progress when I had nothing to report. And at the same time, I started having these dreams of this fungus growing in the field, and I will be in that field. It was a very anxious moment for me. And I needed to grow this fungus and cross this step because I felt like I was a stumbling block, because this whole project, the purpose of it is to give these resistant varieties to farmers, to finally release it to farmers. And you cannot release something to them that you have not confirmed is actually resistant. So I felt like I was a stumbling block between the product and the farmers, because if I cannot prove that these plants are resistant, then they can never move ahead to the farmers. I felt like a failure at the time. So at that point, I realized I needed to find a solution, because finding a solution meant that the project will move forward and this product will finally get to the farmers. And also it meant that I will have to stop hiding from my supervisor, and I will also get better sleep. So I went and did a lot of research on these fungus. I read about what other scientists do in their labs, how they grow it, the optimum conditions for growing this fungus. And then I came up with with a new procedure for growing the fungus. And in the process of reading, I found one of the people had said that they use cooking oil. And at the time, nothing seemed strange. So I also added cooking oil to my procedure. And then I made the ingredients. Usually when you grow this fungus, you put it in a 90-millimeter plate, which is circular. And then you put your mixture of ingredients, and then you place the fungus on top and you let it grow. So that's what I did. And I found a room that had the optimum temperature, which is 17 degrees Celsius. And I placed I went back to the field, got the fungus, placed it in that mixture of ingredients, put it in that room, and then I left. So I went back. I was so anxious, so I had to go back every day to check if there's anything growing. So I went back the first day. And at this time, I didn't know it at the time, but I used to, at the time of doing it, I didn't realize it until when I leave the room, I would exhale. So that's the point I realized I used to hold my breath when I get into that room. And then when I leave the room, I would exhale. I was that anxious. So I will go into that room on the first day. I've held my breath. I check on the plates. Nothing has grown. I get out. I exhale. The second day, I check. Nothing has grown. I get out. I exhale. So I did this for 4 days. And then on the 5th day, when I went into that room, I saw something was finally growing. There was a white, fluffy, cotton-like appearance on the plates. And on that day, I was so excited. In fact, I remember saying, yes, when I was in that room. And that is when I exhaled for the first time when I was still in that room. I was so happy. But at the same time, I did not want to count my chicks before they hatched. So I took this plate and I went to the room with the microscope to confirm if this is actually what I wanted. And I checked it and I confirmed that it was what I wanted. So I let it grow for a few more days. And at the end, after 7 days, it was fully grown. I harvested this fungus and I used it to infect the resistant potato varieties that had been developed by SIP. So after infecting them, there were 31 potato varieties, and after the whole experiment, I ended up finding that 18 potato varieties were completely resistant to this late blight disease, and they will not need fungicide use. So that was a very happy moment for all of us. So after that, I continued with my work and I managed to finish it on time. And up to this day, this procedure that I developed was adopted by SIP Nairobi, Kenya. They still use it to grow this fungus because it proved to be a very effective procedure. Although they did away with the cooking oil because I mean, they found something else to replace it, but still, they adopted that procedure, and up to today, they still use it to grow this fungus. So this whole experience, it taught me that the only thing that is worse than failure is not trying. And although everything may seem impossible, it's only impossible until it's done. Thank you.